Hello guys, welcome back to Techdose, and in this video we will see find the largest area of the square inside two rectangles problem, which is from Leetcode number 3047, and this is based on the greedy geometry algorithm. Let's read the problem statement. In this problem there exist n rectangles given on a 2D plane, and you are given two zero index 2D integer arrays, bottom left and top right. So basically both these arrays will be containing the bottom left coordinate, which is let's say x1 comma y1, and the top right coordinate, which is x2 comma y2. So if you know the bottom left and top right, then you can find out each of the length. So this will be x2 minus x1 and this will be y2 minus y1, and just by using these two coordinates you can make the exact rectangle. So given this information, you can select a region formed by the intersection of the two given rectangles. So there may be some kind of intersection happening between two rectangles. You need to find the largest area of the square that can fit inside the region. Okay, fit inside this intersection region. And you have to return the largest possible area of the square, and if no intersection is possible, then you will be returning 0 as an answer. So let's now look at some examples for better understanding. In our case, we will be given multiple rectangles, and our goal is to find the largest square that can fit in the overlapping area. Okay. Now once you see this word overlapping area, you know that if there is no intersection between two rectangles, then your answer will be 0 for this comparison case, right? Because there is no intersection, so what will you insert? Now this problem is valid only for the intersection case. So let's say there is an rectangle A and rectangle B, and there is some intersection area. Now even if the intersection area is large, but still the intersection area can either be a rectangular area or it can be a square area. It cannot be anything else, right? So when two rectangles intersect, the intersection area will always be rectangular or in the form of a square. So let's assume it to be a rectangle. If you try to fit a square inside a rectangle, definitely some area will be left as a void. So now let's look at how to find the maximum area size you can fit in an intersecting area. Let's assume that there is rectangle A and rectangle B, and it is intersecting at some point. So this is the region of intersection, right? Now if this is the intersecting region, then we have to find out what will be the maximum size of square that you can fit inside this intersection area. Now you can see that the coordinates are given 3, 5 and 8, 7. Let's say you can visually see this, and hence I have drawn it on the other side. So let's say this is the intersecting rectangle which is formed. Now as I said, this intersecting area could be in the form of a rectangle or in the form of a square, right? So in this case it is in the form of a rectangle. Now what will be the max size of the square that you can fit? Now the rectangular length and breadth are different, right? So this is the length, so the opposite lengths are same and the opposite breadth are same, right? So in this case the length is equals to 5, which is equals to delta x, that is x2 minus x1. This is 8 and this is 3, right? And if you find delta y, which is y2 minus y1, 7 minus 5, this is 7 and this is 5, right? Then you get b. So you see that b is equals to 2, breadth is 2 and the length is 5. So if you have to fit a square of largest size into this rectangle, you know that all the sides of the square is of equal size, equal length, right? So if you fit a square here, what will be the bottleneck? The bottleneck will be the smaller one among the length and breadth. So which one is the smaller one? The breadth is the smaller one. So if you want to maximize the size of the square, it will assume the side length equals to minimum of length comma breadth, which will be 2. So you know the side length will be equals to 2. So what will be the area of square? It will be length into length, that is side square, which is equals to 4 in this case, right? So this is how, once you know the intersecting rectangular area, then you can easily find out what will be the maximum size of square which actually fits. And if I have to give it in the form of formulation, then the maximum square area will be minimum of delta x comma delta y. You can assume delta x to be the length and delta y to be the breadth, and whichever comes out to be minimum, that will be the maximum length of the square, and you just square it up because length into length will be the area of the square, right? So I hope this point is clear. So let's move on to the next thing. The next thing to consider is how many intersection cases can arise. And if you start thinking, there will be a lot of intersection cases. I have just drawn 5 of them, but there will be a lot of cases. So how to actually solve and simplify all these intersection cases? Now, simplification is easier. Like, we can make all the intersections happen on the right hand side. What was happening in the previous case is, if I say this is rectangle A and this is rectangle B, let's say the red one is rectangle A, which comes to the left hand side. Okay, so let's say we are comparing A and B, and A comes before B, right? So this comparison is looking like B is to the right hand side of A. But if you consider this case C, and if the red rectangle was A and this was B, maybe in your list whatever is given in the input, it may not be in the sorted format, right? And that is why even if you are seeing something on the left side while moving in the array, actually in the 2D plane it may be occurring on the right hand side, isn't it? So that will actually give rise to a lot of cases. So what we can do is, we can sort it based on the x value, and this x value is the bottom left, that is the starting point, this point. So if we sort all the rectangles based on this x value, then I will be sure that whenever I am parsing the array, and if I find rectangle 1 to the left of rectangle 2, then definitely rectangle 2 will be to the right hand side of rectangle 1 when it comes to the 2D plane. Okay, so this will simplify a lot of cases. Now after this sorting process, everything will come down to only 3 cases, which are these cases A, B and C. I have also drawn other cases, you can see on the right hand side, but these all will be taken care when we just solve this A, B and C cases. Okay, so let's see how to solve them, and you may need to solve the other cases, whatever doubt comes to your mind. After having seen the solution for these 3 cases, everything will fit into place once you have sorted it. So you may need to do some dry runs in your notebook. Yes, that is very much required. Let's see case A. In case A, if you can see, this is case A, right? So the second rectangle is to the right hand side, and you see that this is line y3, this is y3, this is y4, and this one you can say this is y2 and this is y1, right? So in this kind of case, if y3 lies in between y1 and y2, and even if the second rectangle lies in the range of y1, y2, this y3 is actually the bottom portion of the second rectangle, right? So if the bottom portion of the second rectangle is within the range of y1 and y2, as I have compared here, then definitely your y coordinate is capable of intersecting. But let's think that this rectangle was further to the right hand side in such a way that this x3 was greater than x2. Then there will be no intersection, right? So only comparing the y coordinate is not enough. You have to also compare the x coordinate, right? So we have to compare x3 and see that x3 also lies in between x1 and x2. Okay, so we are comparing both y coordinate and x coordinate, that if both of them are intersecting, then only an intersection will happen. And if an intersection happens here, then you have to find out what will be the bottom left part of this intersection. And if you can visually see and solve this, it will be the maximum of this x3 comma x1, and it has to be x3, right? Because x3 lies in between x1 and x2, so it has to be x3. And what will be the y coordinate at this point? It will be y3, because y3 was the one lying in between y1 and y2, so it has to be x3 comma y3. And if you want to find out the top right corner, then you may have to compare this x2, right? So you have to take the minimum of x2 comma x4, because what might have happened is, you might have a case something like this, isn't it, where your x4 was actually less than your x2. This might have happened, right? So you have to compare x2 with x4, whichever is minimum will be present here, and similarly y2 with y4, because what may happen is, you may have a case something like this. Then what? Then this was y4, isn't it? So similarly you have to take care of all the cases. I will show you all these calculations later in the dry run, so you can just assume that it will be x3 y3 and x2 y2, and simply you can find out like what will be the intersection area and what will be the maximum size of the square, as we have already seen. Let's see case B. In case B, we are just finding that if this is rectangle A, to the left and this is rectangle B which is to the right, then we are done comparing the bottom part, and if the bottom part is not in the intersection zone, then we will be comparing with the top part. And if the top part, that is y4, is in the range between y1 and y2, then actually it is a candidate for making the intersection. But you have to also compare the x3, right? The x3 is in the range of x1 and x2. If these two things happen parallelly, then it falls in case B. And now this will be the intersection area, right? If you are wondering about why I am comparing x3 and why not x4, because x3 is to the leftmost side, right? So if x4 is doing some kind of intersection, x3 will do, because we have sorted all the rectangles, right? So we don't need to worry about x4. Now let's look at case C. Case C is something like this. In this case, if this kind of case arises for A and B, then both the previous cases will not be able to determine the answer in this case. So what happens is your x3 is lying in the range of x1 and x2. But once you consider about the y coordinate, the y4 is higher than y2, and if you see this y3, this is y3 is lower than y1. Okay, so none of the top or the bottom is within the range of y1, y2. Yes, that can very much happen, but the x is within the range. So this is creating another type of intersection, right? So these three type of intersections will actually cover all your cases. And let's see one of the dry run in order to understand how it will work out. I would like to announce about our live training programs, Data Structures and Algorithms, which is Interview Dose, and System Design, which is Design Dose. If you are looking for making a switch from service to product based, or even make a product based to product based top tier switch and aiming for your dream company, this is the best curriculum you can ever join. I'll be your mentor throughout the cohort, and I will help you clear all your doubts in the one-on-one sessions. You can know more about this by querying us on the WhatsApp number, or you can also visit our website techdose.co.in. So if you look at this dry run, I have sorted 3 rectangles. It may have been given in any order, but I just sorted it based on the bottom left x coordinate. Okay, so in this case the bottom left x coordinates were 2, 4 and 8. Once you have sorted, you have 3 rectangles A, B, C. I have just given the legend here. And what I will be doing is I will be comparing A with B and A with C. Okay, and then finally I will compare B with C. This will actually give me all possible combination of comparison. And how can I say that all possible combinations will actually work out? Because if you look at the constraint here, the constraint is very light. Like the constraint says that you will have 10 to the power of 3 rectangles, right? So if you have 10 to the power of 3 rectangles, and if you are comparing each rectangle with every other rectangle, the number of such combinations will be order of n square. And if you convert it to order of n square, it will be 10 to the power 6, which is very less than 10 to the power 8. And if we consider this to be 1 second, definitely 10 to the power 6 is going to run within 1 second. So you need not worry about optimizing this, right? So even before solving, you will be able to know if your solution is going to work. And this is a very big advantage actually, because many candidates just lose out a lot of time thinking about an optimal solution which may not exist, right? So let's look at this dry run again. I'll be comparing this first rectangle with the second one, right? I will be comparing A with B, the white one with the orange one. If you compare them, then I will be finding for the intersection area, this bottom left part will be bottom left x coordinate and bottom left y coordinate. These two I need to find. But first thing, I need to be sure if it is intersecting, it will actually be fitting in case A. If you look at it, you can use this condition and it will fit into this condition, case A, right? So once you know that this is case A, then how to find this bottom left x and bottom left y? The bottom left x coordinate will be equals to this x coordinate, right? In between, whatever was x3, that will be the coordinate which is 4. And bottom left y coordinate will be whatever is this coordinate y3, because y3 was within this range, right? So it will be y3. And that is how I have written here 3. Now when it comes to the top right x coordinate and the top right y coordinate, if I have to write this one, then the top right x coordinate will be the minimum of this x coordinate and this x coordinate, right? 6 and 12. So whatever it is, x2 and x4, minimum of x2 and x4 will be here. And again the same goes for the top right y coordinate, minimum of y2 and y4. Okay, so that is why I have written 6 and 8 here, right? So once you have formed the bottom left and top right of the intersecting rectangle here, then after this you know that you will have the information of delta x and delta y. You just take the minimum of delta x and delta y, and that will be the side of your maximal square which you can fit into the intersection area, and simply you square this side to find out the area. Now since I want to maximize the size of the area which I can fit, right, so I will take max area equals to 0 initially, so that I don't know if I can fit something, and as soon as I find a better answer I will just update the max area to a newly found answer, which is 4 in this case, right? So I compared A with B. Now when I go to compare A with C, there is no intersection at all. Okay, so it will not fit any of the 3 cases whatever I have discussed earlier. So there will be no intersection, so the area contribution will be 0, and therefore the max area will remain to be 4. Now when I compare this B with C, then it will fit into one of the cases. You can check out which of the cases it fits into, A or B or C. You just check it out. Once you check it out, you can follow the previous process of finding bottom left x, bottom left y, top right x and top right y, and you will get these coordinates. Again you have to find delta x and delta y. Take the minimum of delta x, delta y to be the square side. Just square it up to get the area, that is this area, and simply you just have to compare if you have improved the max area. In this case, yes, the previous max area known was 4, now it is 9, so I will update this to 9. And in this case I have done all possible combination of comparison, A with B, A with C and B with C. Now A with C and C with A will be the same comparison, hence I will not be doing that, right? And so the answer in this case will be 9. I hope you were able to understand this. Now the time complexity will be order of n square because of the number of comparisons, and in each comparison we are just doing constant operation, finding these 2 coordinates and then just finding out the area, right? So I will be mentioning all these 3 cases in the code. So let us now go to the code and see. If you look at the code here, we were given bottom left and top right coordinates. So I have just stored all of them into the rectangles array, where the rectangles array will contain the bottom left and top right at 0, 1 and 2, 3 coordinates, right? So each of the list inside the list will be of size 4. Okay, so this is how I have converted and stored all the rectangle information at the same place, and then I have sorted it based on x1, that is this one, that is the bottom left x coordinate of each of the rectangle in ascending order. So every rectangle will be present on the number line in order from left to right. Now if 2 rectangles exactly overlap, they have the same x coordinate, then they will be sorted based on the y1 coordinate. Okay, I hope you know this. So once the sorting is done, then I have defined multiple variables. I have defined xi1, it is equivalent to saying x1, okay, and I have defined xj1. So I am comparing this ith rectangle with some jth rectangle. So the bottom left of ith rectangle will be xi1 and yi1, and the top right coordinate will be xi2 and yi2. And similarly for the jth rectangle, the bottom left corner will be xj1, yj1, and the top right will be xj2 and yj2. Okay, so I hope you got this understanding. Based on that I have written the entire code. You can see I have given 2 loops. So ith rectangle will be compared against the jth rectangle, and I will always be doing comparison in the forward direction. So I have taken out all the coordinates of the first rectangle, all the coordinates of the second rectangle, and then this is case A of comparison. Okay, this is case B, and the third one is case C. So this will cover everything up. If you do not find any kind of intersection, I have already assigned max area to be 0. And if you do not find any intersection, when you return the max area, it will be 0 automatically. So if you look at all the cases explained, and if you look at the code, then it will be extremely simple. Yes, you may have to write down on your notebook in order to get better clarity, This code is very descriptive. You will find smaller codes on the Leetcode discussion section, yes. But this I made in order for you to better understand the entire solution. So I hope this video was helpful. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.